implicit differentiation. Well, up until now, most functions we've seen are written in the form of y equal f of x, where y is said to be an explicit function of x, which means given an equation, we can solve for y alone. We can solve for y in terms of x. However, there's equations such as x squared plus y squared equals 25, y squared minus x equals 0, x to the third plus y to the third minus 9xy equals 0 are said to be an implicit function, which means we can't solve for y implicitly in some of these equations. So for example, if we want to find the derivative of this function with respect to x, we have to think of y as the function in terms of x. So here, what we have to remember is think of y as a function in terms of x. It's a function on its own. Now, if we want to take dx dy dx of this function, we'll take derivative with respect to x. So this means this here, we take derivative with respect to x. So let's start with our function. X squared plus 2y squared equals 5xy squared. So let's take derivative with respect to x. Well, derivative of x squared equal to 2x. Now, on this part here, we think of y as the function in terms of x. So then there will need to be a chain rule applied here. So take derivative of the outer function, 2 times 2y, times the derivative of the inner function, that is dy dx. We don't know what the inner function is, but we know that it's a function in terms of x. So the derivative of it is dy dx. Equal, so here we have a product rule and a chain rule. So 5, derivative of 5x is 5 times y squared plus 5x times y squared, that is 2y dy dx. Our next step here is to solve for dy dx in this equation. So 4y dy dx minus 10xy dy dx equals 5y squared minus 2x. So then dy dx is equal to 5y squared minus 2x divided by 4y minus 10xy. Let's try this again. Let's use implicit differentiation to find dy dx for the following. So again, think of y as a function in terms of x. So when you come to y, you want to take derivative. There may be a chain rule that is involved. Okay. So then here 3x plus 3y to the second times dy dx equal 18y plus 18x dy dx. So in the first part here, there's a chain rule that's involved. And in the second part here, we're looking at the product rule. Let's solve for dy dx. So dy dx is equal to 18y minus 3x divided by 3y squared minus 18x. We can simplify this function by 3. Sit y minus 3x divided by, sit y minus x divided by y squared minus 6x. Next one. We have a chain rule on the left hand side, and we have a product rule on the right hand side. And we want to solve. Let's simplify this. We solve for dy dx. So dy dx equal simplify. Next one. So here we have the product rule on the left side, and we have a chain rule on the right hand side and the product rule on the right hand side. The derivative of cotangent equal negative cosecant of x times y times cotangent of x times y. Derivative of x times y, that is y plus x dy dx. And we have to solve for dy dx in this case. And I will leave this to you to do. In the next one, we have a product rule on the left side and also a chain rule. On the right hand side, we have a product rule. Again, I will leave it to you to solve for dy dx. Show that the point negative 1, 0 is on the given curve. Then find the tangent and a normal line to the curve at the given point. So if this point negative 1, 0 is on the curve, then it has to satisfy the given equation. So 6 times negative 1 square plus 3 times negative 1 times 0 plus 2 times 0 square plus 17 times 0 minus 6. This equal to 0. So it checks out. We want to find the tangent and a normal line to the curve at the given point. So first we need to find dy dx. And then we will evaluate dy dx at the given point to find the slope of the tangent line. So to find the slope, so let's first find dy dx. Now that we have the value for x and y, let's evaluate this function. So this now becomes negative 12 minus 3 dy dx plus 17 dy dx equal to 0. This means negative 12 plus 14 dy dx equal to 0. Dy dx then equal to 12 over 14, that is 6 over 7. Then we can write the equation for the tangent line. Y equal mx plus b. So 0 equal 6 over 7 times negative 1 plus b. So b equals 6 over 7. So the tangent line is 6 over 7x plus 6 over 7. Let's find the normal line. The normal line is perpendicular to the tangent line. So then the slope of the normal line equal negative 7 over 6. So y equal mx plus b. 0 equal negative 7 over 6 times negative 1 plus b. Then b equal to negative 7 over 6. So the equation of the normal line equal to negative 7 over 6 x minus 7 over 6. Find the slope of the double curve y to the fourth minus 4y squared equal x to the fourth minus 9x squared at the given point. So here you have four different points. I want you to try this example on your own and let me know if you have any question.